Hi, good afternoon. What I want to introduce today is lab number 5, which is DC circuits. I will go to my canvas now just to show you what I have. All right, okay, let's see here. I accidentally closed all my, okay. And I will go to canvas, quantity, all these things in your report. Data using tables and data only the things that you are measuring, okay? If I'm measuring the voltage, I'm gonna list it. If I'm measuring the, let's say, I'm measuring the currents, I'm gonna list it. I have a source, voltage, I'm gonna list it, the value of the resistors, all these are going to be your input, your data. Don't include any calculated thing. And here I will have sub sections. You will say series circuit and you will say parallel circuit, okay? And this is what you should do, exactly what I'm talking about. And this is how I'm gonna grade the lab. Now for the calculations, you should use the equation editor for all your calculations. No work will be accepted. For this lab, I'm gonna give you 0 for, if you are going to include any handwritten, I will not give you any credit for that. Your series circuit calculations, and again, you have subsections, series circuit and parallel circuit. Percent difference, you're gonna include 1 and 2 for series circuit and 3 and 4 for parallel circuit. I'm gonna talk about these. Results using tables and with the correct number of significant figures, you should list your results. Okay, the answers for the calculations 1 and 2 for the series circuit, and the answers for calculations 3 and 4 for the parallel circuit. The questions, you are going to include the questions in the manual with your answers. You can choose different colors. I prefer maybe sometimes. For the appendix, you are going to have series circuit SNP I will talk about these because I think here there is a misnumbering, and then I'm going to talk about these in a little bit. Okay. Now let's go back to the introduction and the experiment. Of course, here we will not calculate any uncertainties because we are not really doing any actual labs. Now here we are going to have a circuit, and the circuit, it has usually it might have 1 loop, it might have 2 loops, it might have any kind of connections, and it can have any, I will say, electronic components. Okay, the electronic component that we are going to study today are really resistors. Okay, then we are not adding anything, but like we are going to start adding later to the circuit, like not only resistors, we might have capacitors, we might have also conductors, inductors, sorry, and then it's gonna be like a different story. Now, in all these connections, I have 2 options for my loops, okay? Like one of them is the series loop here, where it is a path that it has no choices. It is only one path. And then here I will say the electrons, they are forced to go through that. And I will say, if I have as many components in series, all of them, they're going to have the same currents because this is the only option for the electrons to go through. Whereas if I have parallel loop, then I will have more options. Let me show you here also, like it's good maybe to demo. Okay, like look here for the circuit, like I have only one path where the current is gonna go, all right? Now, when I have parallel connection, when the current is gonna come here to point A, it has an option to go here or here. And this is what we call parallel connection, okay? And of course, like it depends on what I need to do with my circuit, what is the purpose. I will, as an engineer, I will design a circuit either to be like series or parallel or a connection, a combination of these. Now, of course, here we are going to ignore any resistance for the wires. We are going to assume that they don't have any resistance. Also, we will use usually a breadboard to connect so that we will not solder, we will not like twist the wires, we will not, you know, maybe I would say abuse the resistors. Is going to be like a way of connecting, which is neat and good for us to, you know, to go through. Now, I will say we will not have any kind of I will say like of actual values on the resistors. They are color coded. And what does that mean? You will find that it depends on the system. The system that we are using here, they're going to be 3 color bands to denote their resistance. The color code is as follows. Black is going to, if you have a black, is going to be 0. Brown is going to be 1. Red is going to be 2. And you can go to the other values. Now, there is a 4th band here, and this is going to tell us what is really the tolerance of the resistor, what is really the uncertainty in the value of the resistor. We might have a silver band, then it's going to say 10%, 5 is going to be gold. If we don't have that 4th band, then it's 20%. Now, let me here go to where we will be able to learn how to you know, find the value of the resistor from the colors on these bands. Then I will here, this is here. And let's assume here I'm gonna get for the first one brown, and then red, and then I'm gonna get, let's say, orange for the 3rd, and for the tolerance, let's have silver. Now, brown is 1, then I'm gonna put 1. Now, number 2 is gonna be that the red is gonna be 2. Okay, and then now there is a multiplier. The multiplier, orange is 3, then it's gonna be 10 to 3, which is kilo. All right, and then the silver plus or minus 10%. Okay, then like I can have, let's say here, have it, let's say blue. Okay, and have that one, let's say red, then this is 2 times 10 to 6 ohms, plus or minus 10%. Okay. Okay, here, this is really, we are explaining to you here, the first 2 bands, they're gonna tell you the green and red, the first 2 digits are 5 and 2. If the 3rd band is yellow, then we know that it is gonna be 52 10 to the 4. And then the resistance is going to be 52.0000 or 520 kilo ohms. And then if the 4th is gold, then it is going to be 5%. All right. Now, for the measuring devices, we are going to measure the voltage. And today our measurements are DC. And we are going to measure also the current. Now, polarity is important. What does it mean, polarity? Polarity, you must connect the black to the negative and the red to the positive. If you will switch these terminals of the multimeter, you will get a negative number. Then, of course, you should have your numbers positive. One more thing. When I am talking about measurements of voltage, I measure in parallel, which means one probe is gonna be placed to the left and the other one to the right. Okay, and they are in parallel. Now the voltmeters, usually they have a very high resistance so that they will measure the voltage accurately. Now for the currents, we will put our ammeters in series, and the reason is I want them to have the current going through them. Usually they have a zero, ideally zero resistance. Now, of course, we will study the relationship between current and voltage in the coming lab, which is going to be about Ohm's law. And just it's going to be number 6. Okay, we are going to use today Beyond Lab Z and chapter 26 lecture notes. You will use, of course, the pre-lab lecture video, voltmeter, ammeter. These are really virtual, and also the resistors and variable DC power supply and some of the wires. Let me go to Beyond Lab Z and okay, I need to log in here. They are changing, as I said, that connect here, open the Beyond Lab. Okay, I'm gonna open my physics, and then I will wait till it's gonna open this one, and here I don't know why it's like different here, circuits. And now I have my, okay, let me center. Okay, all right, then here I have my Beyond Lab open, and I need to connect the circuit below. You are going to have 2 resistors, then this is 1 resistor, and I'm gonna bring another resistor here. I'm gonna connect. Before I forget, I should like the first one is gonna be 180. Oh, I have an extra 180. Okay, and that here. Okay, and then here the second one, it is 220. All right, and then I will bring more wires. I will bring my power supply, which is going to be positive here and negative here. All right, then this is my circuit. Now your power supply, don't forget, should be set to 12 volts. All right, you will now make several current measurements on the circuit. okay, and you record all your measurements. Okay, then here I will have now to measure current DC. Then I'm gonna look at this here. Oh no, this is the one. I can see amperes DC. Yeah, that's correct. And you will measure the current between the positive terminal of the power supply and R1. Then I will say this is going to be my positive. It should be here. And this is how I'm going to measure the current in series. Okay. Now you're going to measure the current between here. Then I'm going to get rid of these. And I will have here in between. It will not take it any point. Okay, then you should have it either here or here. All right, and you will measure the current. You will call the first one IA and the second one IB. You will measure also the current between R2 and the negative. Then you are going to measure somewhere here. And you are going to call it IC. Now you will take several voltage measurements, connect the red LED of the meter to the one side of the resistor and the black LED to the others to the side. If you are reading negative, reverse it. Okay, then I'm gonna measure the voltage. And now here I need to change this into this VDC. Okay, and then here I'm gonna get rid of this, bring this is the positive and this is the negative. Okay, then this is my reading for measurement. If you, okay, now take a snip of the measurement for part A only, which is the voltage across R1. And then you are going to measure the voltage again across R2. The voltage across R1, we're going to call it VAB. And the voltage across R2, we are going to call it VBC. You will take only the snip for part A and measure the potential difference across points A and C. And this one here, we call it VAC. And the software will not allow you for the meter's terminals to be put across the power supply. And okay, let me see here. And this is the reason why you will do maybe something like this. You know, it will not allow you to do this. And this is the reason why I will, if I will put this one here, come on, here. And here, this is gonna be AC, okay? Then measure the potential difference across points A and C. And this is, we are going to call it VAC. All right, now I'm done with the series. And as I said, you're going to include all these under the data section. You have one snip for the first voltage. Now I will have now, okay, I'm gonna remove these. I'm gonna get, I don't want to confuse you, like for this one here, the parallel, I can have it in different shapes. I'm gonna do it exactly like what we have in, I will try my best to have it the same, like, I don't know how to rotate these. Okay. Okay, let me have it the way that I know. Okay, then it doesn't matter how really the shape is looking, but the connection, I thought it's gonna rotate, it's not rotating. Okay, then here, I wanna get rid of this wire here, and I'm gonna have, pay attention to which one is R1, which one is your R2. You don't want to be messing this. Okay, here, come on, it's very sensitive. All right, then this is okay, and I will have R1. R1 is gonna be the 180, which is the one on top, and 220 is gonna be my R2. Here, because of the series connection, I cannot have it still 12 volts. This is gonna create a very high voltage because the resistance of the circuit will be decreasing. Then I will say we're gonna make it 3. Don't forget. Otherwise, we will have like the wires, they're gonna warm up and it's gonna be like a very dangerous. You will now make several also current measurements on that circuit. Record all the measurements. Watch the lab video for this. We must make some adjustments to do the circuits below by adding 1 ohm resistor in the series to the power supply due to the software. Okay, now, okay, we are going to do that. Okay, then here, I will add another like resistor when I want to measure the current across. I will show you, but just for now, I will measure first R1, which is IAB. Okay, now in my, okay, I don't want to, okay, let me switch so that you will not, because the labeling, okay, I need to maybe to do that. Then I will move this here, move it down, then I will get the 180 here, and the 220 is going to be the one up. Okay, yes, so that you will have the same arrangement, like, because I don't want you to switch the values. Okay, now I need to go back to the current DC, sorry, here, amperes, okay, and I will measure now the current, and that is gonna be the one that is gonna be for 180. Okay, then I will have that current measurement for the parallel circuit, and that is going to be here. No, I want to have first the first current here, the AB. This is the one. Okay, and you will also measure the current for the second one, which is the 220, which is going to be here. All right, and finally you are going to measure the current in you know, across the okay, get rid of it. Okay, we need to have just a resistor. Okay, come on. Okay, let's see here. Because we will not be able to measure the current because due to the software limitations. And all right, then I will measure the current either here or here. Okay, and that is gonna be the current through the source. Okay, then watch here. We must make some adjustment to do the circuits below by adding a 1 ohm resistor in series to the power supply due to the software. I did not adjust the value here to be 1, then so that it will not affect the circuit that much. Okay, then this is really how it's gonna be. Now we are going to do the voltage measurements. Now I want you to know that we should remove the 1 ohm. Don't leave it here. Okay, the 1 ohm should be removed from the circuit before measuring the voltage. Okay, if you will keep it, then this is going to be a mistake. Okay, now then here I will now have it as a voltmeter. Then this is here a plus, this is a minus to measure this. Okay, like I want to find first the voltage across the 180, which is here, and then I will have the voltage across here. All right, and by this I have done all my measurements. Okay, now after that we're going to go to the calculation section. In the calculation section, as I said, you are going to say series circuit, and then from step 5 calculate the average of the 3 current values. You have 3 current values, they should be ideally the same. You're going to measure all the you have measured all the 3. You have to add them and divide by 3 to find the average. From step 6, you are going to add voltage AB to VBC. Then this is your calculation. For parallel circuit, from step 5, add currents IAB and ICD. You are going to measure the currents. And from step, calculate the average of the 2 voltage measurements. Now for the percent differences, you're going to find for the series circuit, find the percent difference between each of the 3 currents measured in step 5 and the average current. Then here you are going to have a 3% difference. And you have to include here all your calculations, not the final answer only. For the series circuit, also find the percent difference between VAC and the answer found in the calculation 2 for the series circuit. Now for the parallel circuit, find the percent difference between current I, which is found in step 5C, and the answer found in calculation 1 of the parallel circuit. Okay, which was really, we have calculated, which was the addition of the 2 currents. And for the parallel circuit, find the percent difference between each of the 2 voltages measured in step 6 and the average value found in calculation 2 of the parallel circuit. Then here you are going to have 2 of them. Now, of course, here, use only 2 or 3 sentences to answer the questions below. Pay attention to the percent difference. Like the percent difference is going to be, I will say, a hint for you to answer these questions. Okay? Don't include any handwritten answers. All right? And then finally, in the results, you are going to include your tables. As I mentioned before, you will have the 4 SNPs. I did not talk about the SNPs. You need to include a SNP of the first one is step number 5, which is the SNP of the step number 5, which is several current measurements. Take a SNP of the measurements for part only A. Then the first one in the series for the current, you're gonna take the SNP. The first one in the voltage, you're gonna take the SNP in series. The first one in the parallel, you are going to take the SNP of measuring current. And finally, measuring the voltage in parallel, you are going to take the first the SNP of the first measurement. This is all for this lab. Thank you very much. And if you have any questions, don't hesitate to ask me. Thank you. Bye.